All right, so this is a screencast on number 4 from the Projectiles worksheet. This is the first one where we have the initial velocity having both a vertical and a horizontal component. So it's a little trickier, it's a harder level. Let's take a look at what's happening here. We have Felix, who is kicking a ball off the top of the corner of a 40-meter high building, and he kicks it at 20 meters per second and at a direction of 20 degrees up from the horizontal. And then the ball obviously is going to interact with a cat, so it's going to land on a sleeping cat. But we're really after the ball while it's in the air only. So this is after it leaves his foot and before it hits the ground, only while it's in free fall. We want to know the total time in the air, where the cat was, how high it went, how high the ball went, and where the final velocity of the ball right before it softly hits the cat. So we get a sense of what's happening here, that this ball is going to leave the edge of the building, it's going to have a parabolic shape, and then it's eventually going to come down and land on the cat. And what we're after is, how do we solve all this information? How do we get all of this data? So in this key, I'm going to go ahead and use 9.8 instead of 10. I know we usually use 10, but I'm using 9.8 to get a little better values and see what happens with sig figs as we do that, as we start to get a little better with sig figs. One problem we have is that font doesn't show up in terms of the degrees. So when you see this little square symbol here, it's actually degrees. So here's our big plan. The first thing we're going to do is find the components of that initial velocity. We need to know the vertical and the horizontal components, and we'll use those components for solving the problem, not the overall 20 meters per second. So that'll be the first thing we do. Then we're going to solve the vertical case, which you're good at from the last unit. Then we're going to solve the horizontal part of it, which is easy because there's no acceleration horizontally. We'll be ignoring air resistance. And then finally, we put it back all together and look at the final answer. So here's how we get started. That initial velocity, we know that the vertical component will be the sine because it's the opposite over the hypotenuse. So we just go 20 sine 20, get our number. For the horizontal, we just go 20 cosine 20, where we have the original velocity, but we also have the angle of 20 degrees. So what does that give us? That gives us the initial vertical velocity, which is what we're after here. Remember that it's positive going upward, and we're only going to look at the vertical up, the vertical down, and then the overall. And for each of those, we have to do a different vertical case. So here we have on the way up, we have here initially, and then at the top, the final velocity being 0. So we'll know VI. Notice we didn't use the 20, we used the 6.84. The final velocity is 0 at the top, and we're going to use negative 9.8 this time for acceleration. So we know 3 of the 5. I put you to work. I'm not going to show this, but you know how to do this. So we solve for those other 2 on the way up, and we now know the S, we'll call it S, going up is 2.38 meters, and we know the time on the way up is 0.698. Now for the coming down, the initial vertical velocity is 0. Now we know it's also moving horizontally, but we're not thinking about that. We're only looking at the verticals. And so we're going to have the vertical velocity being 0 at the top. And we're going to need to find the final velocity right before it hits the ground, right before it hits the cat, excuse me. We'll use negative 9.8. And we now know the delta x because we have the 2.38 that we know it went up, and then we also have the building height, which you remember is 40 meters. So we have S being negative 42.38. So we can solve this coming down part, get the time, and get the final velocity. And we could verify by doing the whole thing with the beginning here and an end here and see that our time ends up being what it's supposed to be. Or we can just add these 2 times together. But in any case, we can verify if we wanted to by doing another set with the x at the true beginning and x at the end. Obviously, you can do these in a different order. You can choose to do just 2 of them and use subtraction. You don't necessarily have to take the time to do all 3 of them. Okay, in any case, the total time in the air is 3.64 seconds. We're almost done now because the horizontal case is so easy to solve. All we have to do is take that total time times the horizontal component of the velocity, and we can see how far horizontally the ball moved. The last bit is a little bit tricky. We have to take that final velocity, which we see here in this little triangle. We need to solve that triangle. We have the horizontal component. You'll notice the horizontal component of 18.8, it never changed. 18.8 here, 18.8 here, 18.8 here, always 18.8 meters per second horizontally. The vertical changed like crazy. It was initially upward, then it was 0, then on the way back down, it's accelerating. So right before it hits the cat, it's going 28.8 meters per second right here. So what we have to do is we have to take these two components, put them back together to find the overall velocity, which will include an angle. Pretty easy, just a little Pythagorean theorem and a little bit of an arc tangent there to get the angle. So that's what this is showing. A little bit of Pythagorean theorem to get the overall final velocity, 34.4, and then an arc tangent to get about 57 degrees down from horizontal. So I hope that helped a little bit. Those are the harder projectile problems. Please come and see me if this is still a little confusing to you. You might want to just replay this video and give it another try on your own. Good luck.